The following videos will serve as tutorials for the new PowerMill Additive plugin. This video will focus on the new Netfabb strategies toolpath. You'll notice that a new tab has been added to the ribbon to accommodate these new additive strategies. Netfabb strategies are 2.5D toolpaths that slice a component at given Z level intervals. There are three kinds of 2.5D paths that we can generate from here: Centerline Offset, Oscillation, and Solid Part. Let's start by looking at Centerline Offset, which creates a path down the center of the component and allows you to generate subsequent offset paths from there. In the Strategy tab, select Centerline Offset and then input a step over for the path and a layer height, which will decide the Z level intervals. There are some important parameters in path control that require attention before calculating this path. Wall offset is the distance from the centerline that the strategy will consider. Anything outside of this will be ignored. The second important figure in this dialog is the number of parallel passes. This sets how many offsets from the centerline will be created. Underneath path control, there is also layer control, which allows for fine adjustments to initial layers where necessary. Process parameters contains information that can be posted to the machine with the right post configured and has simple parameter sets for powder-based and wire arc processes. Before calculating this toolpath, it is important to note that when generated, this toolpath will not be editable as it is not a PowerMill entity. Hiding the model reveals the toolpath. Additive toolpaths are displayed in light orange to distinguish them from subtractive paths. Viewing from the side reveals the individual Z levels, and then from the top, the extra offset paths can be seen either side of the centerline. The second type of Netfabb strategy is Oscillation. This is comparable to a raster type strategy and is suitable for building near net shapes. Select Oscillation from the drop-down menu and enter values for step over and layer height. Below, in path control, there are far more parameters in this path to explore. Each parameter has an explanation at the bottom if clicked on, but here are a few key ones. Oscillation angle sets what the primary direction of travel will be for the path. Note that the oscillations rotate to be as close as they can to be perpendicular to the model walls. This can also be turned off in the path control form. Oscillation angle increment rotates the raster direction by a set angle at the start of a new Z level, which is visible when viewed by layer. Part offset allows you to add stock material to the built component by adding extra additive toolpath. Contour path adds a contour around the perimeter of the part that you can also offset from the raster sections of your path. This is a good way of ensuring that subsequent weld pulls don't escape the part boundary. Toolpath edits can also be performed on these strategies, so that you can reorder paths, change and gauge in link modes, as well as limit paths. The third and final type of Netfabb strategy, Solid Part, is very similar to the result we achieved using Oscillation with part contour. Start by entering similar values for step over, raster angle, and increment. Then add a part offset and contour path. The advantage of using this final type of toolpath is that there is some added control. Smart ordering can be applied to the path to avoid unnecessary retract and engage moves. Flexible raster spacing gives you the ability to average out your raster distance over the part, so as to avoid creating voids in a solid part. Finally, alternate raster direction can help you keep the tooltip down on the part for continuous deposition, or turn it off to deposit in one direction. That concludes this tutorial for Netfabb strategies in the new PowerMill Additive plugin.